Hi and welcome to video 5, and in this video we're going to explore one particular case that doesn't work. So here we go. So we can integrate all powers, negative, positive and non-integer for linear functions, but we can't integrate, and this is what I talked about at the start, we can't integrate that because if we derive that, so if we derive the function d dx x squared plus 1 to the power of n, we would end up with n x squared plus 1 to the power of n minus 1 times 2x. And that gives us 2nx x squared plus 1 to the power of n minus 1, which is all good. We can deal with that because that's in our original question. We can deal with 2n because that's a constant. That guy there is our problem. So if you were asked to integrate, we can't just invent an x because it's the variable in this case. There's nothing we can do. So that is actually not integratable with any skill set that you'll learn in math methods. Of course, you won't be given that question. Now, here's a little bit of bad news. And it's not too bad. But we do have one issue. We can integrate everything except for the integral of 1 over x dx. Okay, this would be the integral of x to the power of negative 1 dx. And of course, using our rule, that would be equal to x to the power of 0, we increase by 1, divided by 0, plus c. And we can't divide by 0. So the integral of this reciprocal function cannot be done. That's the problem. So what it does actually create is a new rule. And you've seen this rule because you know the reverse. You know that there's something here that we can derive to get 1 over x. And equally, there's something that we can derive to get k over ax plus b. But let's worry about the first one. So I'll rub this little star out. Just cast your mind back to some previous work you've done on differentiation. What is that thing such that when you derive it, you get 1 over x, and hopefully you remember it's the natural log of x. So now we're introducing the other functions. If you integrate 1 over x, you get the natural log of x. You can integrate 1 over x squared using polynomials, but you cannot integrate 1 over x. In that case, we get the natural log of x. And here, if we integrate k over ax plus b, well, we get the ax plus b is really important. That's inside the log. Haven't really left myself enough room. The k is just a constant, so if we integrate that k, we still get the k, but of course we have to just be mindful of that a, because if we derive this function, we would get that, and the k would just stay there, but we'd get an additional factor of a, and so this a here deals with that. And if that's a bit confusing now, you'll see through some examples and practice how that works. And of course, that's kind of the rule as well. So here are the rules, and I'll write them out nicely for you. The integral of 1 over x is log x plus c, but more importantly, and I haven't got a k on this rule, but you could have a k here, the integral of 1 over ax plus b is the natural log of ax, so that's ax plus b plus c, but we do have to have that 1 over a out the front. And so let's do some examples. Example 7. 1 over 2x plus 3 dx, and hence determine a particular solution for y if dy dx equals 4 over 2x plus 3 dx. So the first part, I might even just denote this as a. In question a, the integral of 1 over 2x plus 3 dx is equal to the natural log of 2x plus 3, that's a 1, with a half at the front plus c. So you've got to deal with that extra 2 factor that will come out if we derive this. And so we get a half log 2x plus 3 plus c. And that's part A, but this is part B, which is the further, taking the question further, maybe even taking it into that complex familiar range. And hence determine the particular solution for y if dy dx equals 4 over 2x plus 3 passes through negative 1, 2. So we've got dy dx is equal to 4 over 2x plus 3. And so therefore y is equal to the integral of 4 over 2x plus 3 dx. And I can actually write this down now. I can take that k value, the constant, out the front. 1 over 2x plus 3 with respect to x. And we've already done this calculation. It's 4 times a half natural log 2x plus 3 plus c. And so this becomes 2 natural log 2x plus 3 plus c. So that's the start of part B, but I have a known coordinate here as well, negative 1, 2, and so I can put that in. Y is equal to 2 log 2x plus 3 plus c, and so 2 is equal to 2 natural log of 2 times negative 1 plus 3 plus c, and 2 is equal to 2 natural log of 1 plus c. So e to the power of what equals 1, or the log of 1, hopefully you remember that that is 2 equals 2 times 0. So e to the power of 0 equals 1 plus c, which means that c is equal to 2, and therefore y is equal to 2 natural log 2x plus 3 plus 2. And there's my answer to question B. So have a look back through that question, or the whole question indeed, and you'll see the process that we followed to get to there. So in this video we've explored a couple of things and found that you can integrate using polynomials every single power, whether it's rational, irrational, whole number, negative, decimal, etc., except for 1 over x, or a variant on 1 over x, and that just introduces the log rule. And here is the work associated with that from the textbook, exercise 9c, and also the content detail, so hopefully by the end you can deal with that content detail. All the best.